Hello and welcome to part 7 of AVR 602. This will be covering chapter 8, where we get into the nitty-gritty of programming our scripts in C# for our project. We'll be able to set up Unity events and input actions as well. So all of these features have been just using the Unity editor interface, which is kind of just the surface of the iceberg. C# is what's going to allow us to have the most influence in terms of designing our project. So again, Unity runs in the programming language C#, which is very heavy in terms of object-oriented programming. You should already be somewhat familiar with writing Unity scripts from AVR 600, but just as a refresher, Unity has a lot of built-in classes and functions to help with VR development, including the following. You have scripts that can be used for interaction, like button presses on controllers, for interacting with objects, movement and teleportation, physics and collision detection, AI and NPC or non-playable character behavior, as well as user interface, animations, and sound. All of these, we can integrate them and allow for them to have more sophisticated capabilities than we have been doing with the previous demonstrations. Now, all these green slashes just mean that I've put the project onto a Unity cloud. You don't have to worry about this. But if you remember from previous Unity classes, in order to add a script to an object, let's just say I wanted to add a script to this lamp, I could just go to add component, name the script whatever I want. Let's say I wanted to call it script, and I just click on new script, create an add, and it'll create a script for me down below. I can also go to create in my assets, C# script up at the top here, and it'll allow me to create a script with whatever name I choose as well. You should already be familiar with some of the programming fundamentals like variables, which can be declared as a data type to hold a specific value. Some of those data types include integers, floating point numbers, doubles, characters, strings, etc. You also have operators like adding, subtracting, multiplication, division, and modulus for arithmetic, as well as a lot of the Boolean operators such as equal to, not equal to, greater than or equal to, less than or equal to, greater than less than. A lot of the control flow statements or keywords like if, for loops, while loops, etc. There's also classes that each have their own methods and functions. Unity has a whole library of built-in functions and methods for their objects. For example, game objects or vector 3s. If you can think of an object, it probably has plenty of methods or functions and attributes that you can find just by going online and looking up the Unity documentation. Now, if I were to create a new script from scratch and just call it script in my projects folder, and I double click on it to open it, that should open up whatever version of Visual Studio I have installed. The typical template for a script will have this mono behavior. This is the name of the script, by the way, not just script. So if I called it player controller, this would be called player controller. Mono behavior is the class from which every Unity script derives from, as it says as I hover over it. And I have two main functions, as the comments say. This will kind of be where you initialize the values of all of your variables, and then this will be called every frame on repeat. Now, if you remember from your experience in Unity programming, you can set private or public variables. So let's say I want a public or a private integer called private int, and maybe this could be something that I calculate rather than enter manually, as it could be important for movement physics or something like that. But if I want to kind of tinker with a value, I don't know what the value is going to be, and I want to be able to play test with it, I want to make it public. Because if I save this script and I go look at the script in the inspector back in Unity, for example, say I go back to one of my original scenes and I decide to give this script to the cube, it's going to be asking for this public int, and I can set it in my inspector here. So that's the difference between public and private variables, is that they can be edited in the inspector. Now, beyond just start and update, there's plenty of other commonly used functions or methods that you can include in your scripts. That includes things like awake, which begins once the component for the script is called and loaded. Before the start method, you have things like on enable when the object is enabled, on disable when the object is destroyed, on destroy, collision enter, collision exit when things run into each other. You have other methods like find object type. Get component is really useful when you're looking for a specific game object's component. That can include anything like its mesh renderer, its collider, another script, things like that. I won't be going over some of the common statements like for loops, for each, and if statements. I assume that you already have a strong enough programming background to not be confused by those things when you see them. Something a little less basic you may or may not have seen is using arrays in C#. You can define an array by giving its data type, indicating that it's an array with these brackets, and initializing how many spaces. You have to determine how much memory you want to allocate for this array structure using this integer here. The switch statement is kind of like an elaborate if-else block, or in the case of this variable is 1, you execute this block of code, break. If it's 2, you execute this block of code, etc. If you don't include the break, it will continue down and doing these other cases as well. Another thing that's important for Unity scripting is coroutines. So a coroutine is a method that can be paused and resumed, allowing you to perform actions over a period of time rather than all at once. Coroutines are useful for creating animations, delays, or other time-based actions. So here's how you would create a coroutine. Within the start function, you would type essentially the keyword coroutine, give it a name and a delegation as an argument, and you would define it here of the type IEnumerator. There's some code you would execute and starting a while loop with some kind of condition while the duration hasn't elapsed. You would execute all of this using a yield return, which waits for the next frame. So for our first demonstration, we're going to go ahead and start getting an object to rotate. We should be able to do this already using an animation, but we can actually do it using a script instead. So this is a new chapter. We'll go ahead and create a folder for scenes in chapter 8. They actually haven't given me a name for this yet, so we'll just call it new. So let's go ahead and add some primitive objects again, like our familiar plane at 0, 0, 0. I'll also add cube 0.50. I will also add a cylinder and a sphere. Let's actually kind of separate them a bit. So I'll put the cylinder over on the right side, let's say at 3. The sphere on the left side, a -4, or sorry, -3. Oh, sorry. Let's put our cube over on the left at, let's say, -3. So next, I'm actually going to add my VR rig prefab to this, the one with physics. Drag it somewhere over here. And what we're going to do is we're going to create a new script that will allow us to rotate objects. So I'm going to create folder and call it scripts. That'll contain all of the future scripts that we create. I'm going to right click, go to create, and type C# script. And I'm going to call this script rotate object. We'll go ahead and open it. So in order to make an object rotate, I pretty much just need a rotation speed along with the object's transform. So I want to be able to tinker with the rotation speed in play mode, so I'll make it a public float and call it rotation speed. Usually they use what's called camel casing, where they start with the first word as lowercase and then just capitalize the first letter of every preceding word afterwards when it comes to naming variables like that. So I have our rotation speed. I don't need to set it to any initial value because I'll be setting its value in the editor. So this start function is completely unnecessary. I could either delete it or leave it empty. And in update, I'm just going to simply rotate its transform. So I'll do transform, which is the transform attached to this game object. If I press dot, the IntelliSense I have will give me suggestions. These wrenches are different attributes, and these boxes are methods. I want a method that'll rotate my object. So if I look here, I can click rotate, and it says applies a rotation of Euler angle z around the z-axis, x around the x, and y around the y using this vector 3. So if I want it to rotate around the vertical axis, I'll give it vector3, which is a 3D vector, dot up. So that's the vector that points up in the z direction. So it'll rotate around that vertical axis, and I'll multiply this by rotation speed. So the higher the rotation speed, the faster this will rotate. And lastly, I'm going to multiply it by this value, time dot delta time. That's so that if the game lags and the frame rate goes down, it'll maintain its speed. It won't be influenced by that because it's the interval in seconds from the last frame to the current one. And then I'll click save. Now what I need to do is drag this script onto an object such that it'll rotate. Well, it may not be as noticeable with the round objects because they're symmetrical, but if I were to drag this rotate object script onto the cube, it might be a bit more noticeable. I'm going to need to set the rotation speed to something non-zero, so let's start with 1. If I go into play mode, I won't need to put on my headset for this. When I go to my scene view, I'll be able to see the cube rotating. So it's rotating, but it's going very slow, so I can drag this up a bit higher, and you can see once I hit 40 or so, it rotates pretty quickly on its own. So this is an example of a very simple script that uses a public variable, which means I can actually adjust it in the editor, in the inspector. So essentially, this is an alternative to creating an animation in Unity, but it's less flexible. If we wanted to trigger the cube to rotate under a certain situation instead of it rotating automatically, that's when we should use a C# script as well. So let's make a script where the cube will rotate only when we point our VR controller at it with its ray interactor. And it won't rotate if the ray is not hitting the cube. So let's go back into our script and edit some more. First, I'm going to introduce a Boolean, which is a true-false value called isRotating. And so I can toggle this on and off based on my ray interactor. So instead of this occurring every frame, it'll occur every frame if it's rotating. So I'll go click on if is rotating, and then include this now in the curly braces to indicate that it will only rotate when this Boolean is true. Now what I'm going to do is I'm going to create my own method called public void toggle rotate. The reason that I'm making this public is so that I can access it in my events. If you remember from earlier, when I make something an interactable, so for example, let's say I go to interactable, I have simple interactable, I was able to choose some of my events when I hover, when I exit, and because I make this method public, it'll show up as an option. Whereas if I made it private, then I want to be able to. So to toggle it, I'm just going to invert this is rotating equals not is rotating. So if it was true, it will become false. If it was false, it will become true. Now to add another method, public void rotate. In this case, I will set is rotating to true. And lastly, if I want to specifically set it to not rotating, I'll create public void not rotate, in which case I set this value to false. And then I'll save. So now that we've written this script, we can go ahead and set up an interactable. So as the book mentions, you go into the hierarchy and add the XR simple interactable. I happen to guess that we would use this one, which we do. Let's make sure we drag in our interaction manager. And they want us to set our interaction layer mask to grabbable, which is not here. So I'll have to add that as a layer. Let's add it to 10. Call it grabbable. Enter. Go back to our cube and set that. Looks like I accidentally gave this to the cylinder, so let's remove this and add it to the cube. Simple interactable. And now that we have that layer set up, we'll call it grabbable. It says mixed. Make sure we unselect the other default. Now if I go to hover and click hover entered, this is where I'm going to allow the object to rotate. This script will execute when I am hovering. So I'm going to add the cube to the reference slot because this is the object whose component, the script, I'll be manipulating. Where is it script? Here it is, rotate object. And now I can actually choose some of these values. And I'm going to choose rotate because I want to set rotate to true. For hover exited, I'm going to make it stop rotating. So I'll drag the cube in, go to rotate object, and click not rotate. So now if I go into play mode and interact with the cube with my head mount display, it should rotate. Yeah, so now when I hover over it with the ray, it'll start rotating. And then if I take my ray off, it will stop. This can apply to almost any function now, that when I interact with it, I can write a script and make the object do what I want. Now you may have been wondering, what about the left hand? I wasn't able to interact with it initially because its interaction layer mask was set to object, while the rights was set to everything. So if I want to make this interactable for the left hand, maybe I should set this to object and grabbable. Why not? I'll hit play again. So now if I go ahead and try to touch the object with my left hand, it will start to rotate, but only while I'm actually making contact with it, which is a bit difficult to do since my player has a collider. But now I can use both types of interaction to make the object rotate. So in this next section, we're going to look at input actions again, but with using scripting, and dive a bit deeper on how we can create custom button interactions that can be triggered by code and perform a wide variety of functions. All right, so input actions are specific user inputs or gestures that are mapped to a particular action or behavior in the VR experience. And so we're going to create custom input actions that allow us to use all the buttons on our VR controllers. And once we have these, we can use code to trigger events using specific button presses. If I go to my XR origin or XR rig and click Input Action Manager, I have XRI default input action as my action assets. If I double click on this, it'll open this window up for my input actions. If I click the plus button on action maps up here, it will allow me to create a new action map. And I'm going to call it custom inputs. Then up here, I'm going to click Save Asset. So here I can define a handful of new input actions where we can make custom actions to pair to buttons. So in actions, I'm going to create a new action and I'm going to rename it. So I can right click, rename it as menu button. Set the action type to button. And under this binding here, I'm going to select generic XR controller. They're asking for a path to this menu. I'm going to select XR controller. Optional controls. Then click menu. It wasn't working when I clicked on it for me, so you may need to press the enter key on your keyboard. So what we've done is we paired the menu button with an input action, and now we can do the primary button. So to add a new input action, click this up here, the little plus, and call it primary button. I'll also set the action type to button, and for the binding, I'm going to click generic XR controller again, but this time the path will be XR controller, optional controls, primary button. It's already navigated to this area for me on optional controls, so I just have to click primary button, enter. Then I'm going to save the asset. We can also add a secondary button, which will go through a similar process. We're going to name it as secondary button. Make sure the action type is set to button. And for this binding path, I'm still going to use generic XR controller and go to secondary button. Enter, save the asset again. Now let's say I wanted an input where the user holds a button. So I can actually duplicate this by right-clicking, click duplicate. And I'm going to rename this as primary button 1 underscore hold. Probably rename this with a space for the sake of consistency. But under binding properties, I'm going to press the plus for interactions area here, and I'm going to click hold. Don't worry about these default settings, I'll just save them as is. I'm going to do the same thing for secondary buttons, so I'll duplicate it, rename it as secondary button underscore hold. and add an interaction for hold. Now, what if I want to have an input action where I'm pressing multiple buttons, like a combination of inputs? I can do that as well. I make another action, and I call it primary button underscore trigger. I can select the plus and choose add a binding with one modifier. I'm going to want that to be my only binding, so I can remove this other one. For the composite type, I'm going to choose button with one modifier. I have a button reference here. That I'll set its path and binding properties over here to primary button. As for the modifier over here, I'm going to set its binding properties path to trigger pressed. Then I'm going to repeat these steps for a secondary button trigger. So again, I'll hit this plus and choose add binding with one modifier, remove the other binding that I won't need. Select this as button with one modifier such that it matches, and then set the button to secondary button, enter, and have the modifier be secondary, also trigger press. Now we have input actions for the trigger, but we can also have them work with the grip as well. So I'm going to duplicate the primary button trigger. So I'll press Control D, but I'm going to rename this as primary button underscore grip. I'm going to change this modifier path to actually be primary button underscore grip pressed. It'll also repeat this process for the secondary button trigger. So I'll press Control D to duplicate, rename this as, instead of underscore trigger, underscore grip. Drop this down, change the modifier to grip pressed. Now, after saving the asset, we can create an action for the grip and trigger press at the same time. I'm going to create a brand new action slot and call it primary button underscore 2mods. So now this is going to have two modifiers. I'll hit the plus and choose add binding with two modifiers. Get rid of the old binding. And for the composite type, I'm going to select button with two modifiers. So this says button instead of binding. For the button reference, which is here, I'm going to set the path and binding properties to primary button. Primary button. For modifier 1, I'll use grip pressed, and for modifier 2, I'll use trigger pressed. I'll save the asset. Once everything's said and done, my custom list of input actions should look like this. This will allow us to utilize all the buttons on our controllers and create more engaging experiences. Next, we're going to talk about Unity events and how they can enhance our input actions using code. So in Unity, there's a way to communicate between different components or scripts in a game. We saw that earlier by using public variables. Events allow you to send messages to other scripts or components without having to explicitly reference them. And these are defined using Unity events as part of the Unity event class under the Unity Engine Events namespace. So Unity events can be used to trigger actions like playing a sound, displaying a message, changing a variable, etc. And Unity events can be used to invoke methods, change properties, and send custom messages. This essentially allows parts of our project to communicate with each other without even knowing about each other's existence, which makes it easy to add new functionality to a game without having to change existing scripts or components. So in this section, we're going to use input actions we previously made by creating a new C# script and call it basic input action manager, adding an empty game object within it to reference the input action asset that we've made earlier. So what we'll do is go into the scripts folder and create a brand new script. So I'll right click, create C# script, and this I'm going to name basic input action manager. I'm going to be adding this to a game object. So I'll make a new empty object and call it basic, excuse me. I'm going to create a new empty game object and call it managers. For my first manager itself, I'm going to make an empty game object, which I should apply this script. I'm going to give it the same name of basic input action manager. Drag it on such that it's a child of the manager's empty object. Now I'm going to open the script in Visual Studio. So as per usual, it opens up my IDE with the void start, void update, and some of the using libraries. So I'm actually going to make a handful of changes to this script. First, I'm going to need to include some libraries, including the Unity Engine input system. So I'll type Unity Engine dot input system. And I'll also need the events library using Unity Engine dot events. I won't need start or update for this script. Actually, I'm only going to need awake. But first, I need to define some public variables. So first, I'll define input action asset action asset. Next, I'll declare another public variable called, well, it's of type input action reference. And I'll just call this action reference. And lastly, Unity event, action event. Now on wake, I'm going to define this as a private function of void return with no arguments. If I highlight this, it describes it as awake is called when the script instance is being loaded. I'm going to use this action reference and go to its attribute action dot performed plus equals on button pressed. This is a function that's going to be declared later, which is why you may be wondering if I'm referring to this. Hasn't been defined. I'm also going to include a private method for onDestroy. This will execute when its object is destroyed. I'm going to use action reference dot action dot performed minus equals on button pressed. And now I'm going to define that method private void on button pressed. It will accept an argument input action dot callback context. And in this argument, I'll do action event dot invoke, which invoke all registered callbacks. Okay. With this code, you'll be able to trigger an event using a function of code and an input action referencing one of the buttons that we've made in our input manager earlier. This script was created as a way to pair input functions using the Unity event system. It's pretty simple but effective, and what we can do now is use a button to toggle the rotation of the cube on or off instead of hovering over it. So in order to do that, we can go back to our rotating script. Now we're going to be referencing this toggle rotate method that exists in the rotate object. So in the basic input action manager, this object we defined, I'll go ahead and set its transforms to zeros. I'll go ahead and add this basic input action manager script to it. And you can see here, it has an action asset, action reference, as these are all public, and my action events that all show up in the hierarchy because I made them public. As mentioned, I have the action asset, action reference, and action events. So I can go ahead and add the cube to this reference slot because the cube was the object that was rotating. So if you remember, these action events showed up when I was using my interactors. When I created direct interactors, ray interactors back in chapter 3, I believe, we were able to determine what happens with these interactions. But now I'm able to actually set up button presses that will cause these events to happen instead. And I can customize this in a variety of ways. So I'm going to choose that function from the rotate script and choose toggle rotate. Now this will determine the buttons that I can press. In order to set up the button presses that correspond to this, I can click on Action Asset, the circle over here, and choose X or Y default input actions. As for the action reference, I can do the same process, but I'm going to choose custom inputs. These are all of the custom inputs that I created just a few minutes ago. As you can see, I have menu button, primary button hold, primary button grip. In this case, I'm going to choose the primary button, double click. So that will be the button that causes this action event to occur. So after mashing some buttons, it turns out that when I press A, I can toggle rotation, rotate, stop, rotate, stop rotating, rotate. I also have it be able to rotate on hover. So now, not only am I limited, I'm not just limited to using the basic interactors I've set up, but now I've actually made it so I can trigger these actions with simply the press of a button. Next, we're going to make a script that'll toggle the visibility of a game object by doing the following steps. We're going to create a brand new script, and this time we'll call it toggle visibility. Now, to toggle its visibility, I can just set it from active to inactive. All I have to do is create a public method for this, public void, and we'll call it toggle visibility. Kind of a hard word to spell. All right. So we'll define a Boolean, true or false is active, and that'll be equal to not game object dot active self. If I see the description, the local active state of this game object, game object dot set active is active. This will deactivate the object depending on the true or false value. So every time this function gets called, it will simply invert the current true or false value I have here and set active based on this value. So it'll essentially flip-flop from visible to non-visible and save it. Now this all applied to my sphere game object. So I can either drag the script on or I can add it as a component by typing in its name, toggle visibility here. Now it has it, and I'll have to set up this script in my basic input interaction manager. I'm going to duplicate the basic input action manager as a separate one for this sphere. In the script, I'm going to set the action reference to something else this time. I'll assign a different button. Let's do the secondary button. Here's my custom inputs / secondary button. And instead of the cube, I'm going to drop the sphere in here. And I'll go to toggle visibility. What function do I want to trigger? The toggle visibility. Looks like it's not showing up, and that's because toggle visibility, the member names cannot be the same as their enclosing type. So we'll have to name this something else. Let's call it toggle active instead. Save it, let it compile. So now I'll go ahead and toggle visibility again and choose toggle activate, toggle active. There it goes. Looks like I have to hold it for a certain amount of time or else it doesn't really. But it works. So next, we're going to create an input manager that allows us to create multiple buttons. I'm going to go into my scripts folder, create yet another script, and this time I'm going to name it Input Action Manager. This script will act as a manager for multiple inputs. I'm going to need to have some of the same libraries using Unity Engine dot events and using Unity Engine dot input system. So here's what I'm going to add to my script. I won't be using the start or update. First, I'll add in square brackets system.serializable public class. So I'm going to define a class for instances of custom actions. Similarly to how I did it for the basic input action manager, I made a public string action name, a public input action reference called action reference, also a public unity event called action event. So every custom action will have an action name, an action reference, and an action event. I'm also going to add this public input action asset called action asset. Also a public custom actions array. So this will be a list of actions. Custom actions. Now, just like how I had onAwake and onDestroy for the basic input action manager, I'll do the same for this one. So I'll define private void awake. And again, this will occur when the script instance is being loaded. And I'm going to call this for loop that will run through all of the actions I have defined. So I'll start at index I is 0, less than actions.length. So this will iterate through the entire list. It should be a basic for loop. You should be familiar with how to do this in C# syntax. So if that action, so actions I dot action reference is not null. So if it's a null action reference, I can just go ahead and skip it. Otherwise, actions I, so that action in the list dot action reference dot action dot performed plus equals on button pressed. This follows pretty much the same thing as what the basic one did. So on awake, you added this on button pressed, and then on destroy, drag from the on button pressed. Oh, sorry, this should be actions because we're referring to the list of actions. And again, this on button pressed method will destroy, or sorry, this on button pressed method will be defined a bit later, like we did for the last time. And then we'll do a similar for loop for the on or private void on destroy. So for int I equals 0, we'll iterate through the list again. I is less than actions dot length I plus plus. We won't need to check if it's null because it's on destroy. Dot action reference. So if actions I action reference dot action dot performed minus equals on button pressed. And then lastly, we'll define the on button pressed method. Those will be private void on button pressed. And for this, it'll take similarly, it'll take this input action callback context as well. Input action dot callback context, and we'll call it context as well. This will also iterate through multiple inputs. We'll follow the same for loop. Actions dot length I plus plus. But now I'll include this if that action reference is non-null and actions I. Oh, it's because I didn't set this I to 0. There you go. They should all be I. I don't know why I didn't pick that up. And actions I dot action reference dot action equals equals context dot action. These circumstances, actions I dot action event dot invoke. So here's essentially what the full script looks like. I'll save it and let it compile. Oh, so in the inspector, I'm going to create an empty object and call it input action manager so that it matches the script. This will be a child of my managers as well, and then I'll drag the input action manager script onto it as a child. And for this action asset, I'm going to choose the defaults, my only option. And under actions, I'll click plus on this drop-down menu for element 0. So you can see for the basic action manager, I only have one category for each kind of action event. But here, I can actually add multiple elements to this, and that will be the list that it iterates through. In the action name, I'm going to call it thumbstick press, because that's a button that we should have access to. So it looks like the book completely omitted setting up the inputs for the thumbstick. So we need to go take care of that. So I double click this, go to my custom inputs. I'm going to add another one called thumbstick. And it'll just be a button. And so as for the path, I'll have this set to generic XR controller as well. And then for the path, I'll go to XR controller, enter, optional controls, enter. And there should be one called thumbstick clicked. Here it is, this one. So for some reason, they didn't include that in the demonstration, but the final list included this. So I'll save the asset, close. And now, when I go to my input action manager here, I should be able to add that as an action reference. If I type in thumb, there it is. Custom inputs, thumbstick, double click. Now for the action event, we can determine what will happen with this. For this, I'm going to make a reference to the cylinder object now, drag it here. And we'll just have it change its mesh render material to something. And let's give it like the blue metallic color. So I'll go to my assets, materials, and chapter 4 here. Go to my input manager, drag the blue metallic on. So with this input action manager, where I made an entire list of these to iterate through, when I add these are all the events that will happen when I press the thumbstick. But this can actually handle multiple types of inputs. So for this one, I'm going to make the action name as the primary button. So I'll go to my input action reference, type in primary, go to custom inputs, primary button, and I can make this do something completely different. Maybe I want to have the cube rotate like earlier. So I can drag in the cube. Let's say I wanted to make this a purple standard instead. And then, for example, I want to make another one for my secondary button. For this reference, I'll go to secondary. And then maybe I want the sphere. And oh, sorry, I should have chose mesh render or material for both of these. I don't think. Oh, make sure you drag the actual cube object in. I that up. Click on mesh render, material. I guess we can make this like a green. Okay, let's go ahead and try this out. All right, so now this might actually trigger multiple things. So I press the secondary button, it actually makes the cube turn purple and toggle its rotation. Then if I press the top button, it makes the sphere turn green and disappear. I still have those other input menus. If I press the thumb button, it makes the cylinder turn blue. So it turns out that I'm actually able to have all these different button presses and all these different actions under the power of one script, which is a truly versatile tool. All right, so now we're going to work on something that can be a bit helpful to your project. We're going to use primary button hold input action with a scale up function and secondary button hold with a scale down function to increase and decrease the size of a game object depending on how long the button is held. So we're going to make a new script. We can save this in our scripts folder, right click, create, C# script, and we're going to call it toggle scale. So similarly to our other input action manager script, we had an input actions, action asset, and references. So for this one, we're going to need two. We'll have our public input action asset, input action asset. Reason this isn't showing up is that I forgot to include our libraries using Unity Engine .input system. I'm going to have two input action references. There's going to be one for scale up, and then I'm going to have another one for scale down. Now, in order to quantitatively fit the scale or make a number for the scale, I'm going to use a vector 3 and call it initial scale. This should probably start out as 111, but we'll see how we use it. And then we're going to have true or false boolean for is scaling up, and one for is scaling down. Just because it's not scaling up doesn't mean it's scaling down, which is why I need two booleans. It could just be not scaling at all. And so in our start, we'll define what the initial scale is. The initial scale will just be equal to the initial scale of our transform. So look at transform and type in local scale. I'm going to just enable this right off the bat. My input action asset. And so for scale up, which is my input action reference, I'm going to do .action.performed plus equals ctx is scaling up equal true. Scale up .action.performed plus equals ctx arrow is scaling up equals false. And then I'll have these other what are called callback contexts for my scaling down. So is scaling down equals true, and then one for false as well. You could probably just copy and paste this. And then when the object is disabled for any reason, or sorry, destroyed, I will disable the input action asset. So type input action asset dot disable. And then for the update frame, and then for the update frames, I'm going to determine whether I'm scaling up or down. So if my object is scaling up, what I'm going to do is I'm going to take its transform, local scale, and I'm going to scale it up. So I'll add to it a little bit. Let's add a new vector 3, and we'll give it an x, y, or z. So we'll scale it up by 0.1 as a floating point number, 0.1, and x, y, and z. And then if it's scaling down, we could do the same thing, just subtract from its scale. So we could just take the same code and actually subtract that vector. So whether it's scaling up or scaling down is going to depend on these booleans, and we can set them using some of these functions that can be called by our interaction manager. So when we press certain buttons, we can call scale up or scale down toggle or set these. So if it's scaling up, scaling down will be false, and then is scaling up will be true. We'll have another function to set it to scale down. Oh, sorry, this should also be void as well. It doesn't return anything. There's no data type assigned to these. It just changes these values. So then I could swap these. Make is scaling down true and make is scaling up false. And then lastly, I'm going to have a public void scale null, which means that neither is being scaled, so I'll set both to false. So is scaling down and is scaling up will be false. And then save the script, let it compile, and we can apply it to our sphere game object. I also realized my software crashed while recording in a previous session, so I had to recreate the input action manager. So if there's any differences that arise, just know that it may have been from that. So this should have been here with all these different mesh renders based on me pressing different different buttons. It would give me different materials. But what I'm going to do is I'm going to add another action name. So these are all my actions. I'm going to name it. I'm going to give another action. It's actually this bottom plus right here. And I'm going to give this a different name. So for the action name, I'm going to call it scaling up. And for the action reference, I want to hold the primary button. So I'll look at my custom inputs, custom primary hold. The only one that matches this. And I want this to occur on my sphere game object. So it looks like I've already dragged the sphere, and I can just double check that this is the actual object. But instead of the mesh renderer, I want to go to my toggle scale script and click scale up. And then I'm going to add 2 more actions for scaling down and not scaling. Let me shrink these. So this will be scaling down. It'll occur when I hold the secondary button. So I could type in custom secondary hold. And this will be toggle scale down. Turns out I actually don't need one for the null, so I'll just get rid of that. So we can go ahead and test this too. You can see when I hold the button, it starts growing the sphere, and then only when I hold it, it starts getting smaller, but you can't see it because I also set that to toggle. So I'll just disable this other input action manager for now so that I can't just toggle the visibility like that. These were both accidentally set to be, it looks like I didn't make this scale down. I either didn't change it or it maybe didn't save. But let's make sure that this is the custom inputs secondary hold. And make sure that this toggle scale is scaled down. Okay, let's try it again. Okay, so it scales up. Hold the other button, it scales down. Maybe you want some kind of third action so that it doesn't, that it holds scale or calls that scale null. But there's actually a difference between me tapping the button and me holding the button, because those actually do 2 different things. All right, so another way we can trigger some of these actions is through colliders when objects touch each other. If you remember, we have functions like on trigger enter or on collision enter, things like that. So for example, if a user's hand touches a trigger collider, it can cause a certain action. We can also have that occur while they're pressing a button. So maybe the user has some kind of custom input interaction to grab something. If they press a button or another button while in contact with something, we can set that up as well. So in order to set up a collider controller, we can create an empty game object and give it that name, collider controller manager. So based off of collisions instead of basic input or just input, it'll run based off of collider interactions. Instead it's transformed to zeros. It doesn't really matter. It won't have any kind of mesh. Actually, we're going to add a cube to this actually. And we'll just call it collider controller. We'll set its X position to -1, its Z position to +1. And we'll give it some kind of blue transparent material, which we may already have. Let's see, here's one. There's one for the hand, so I can give it that. And then we'll also create a new script. This will be placed on the Collider controller game object, so we could just go to add a component, and we'll call it Collider space controller. Actually, I can make it all one word. It'll ask me to make a new script with a new name because that component doesn't exist already. This should also be saved in our scripts folder. And I'm going to give it the following code. I'll get rid of its start and update methods. First, I'm going to be looking for a specific collider with a specific tag. So I'm going to name a public string as that to look for what object I'd be colliding with, and create 3 Unity events. There's going to be an enter event. So Unity event, enter event, public Unity event. There's going to be also stay and exit. These have squiggly lines because I didn't include my libraries yet. I need to make sure that I'm also using Unity engine.events. Okay. So this will be the object tag I'm looking to collide with. When I first collide, when I'm staying in contact with the object, and then when I exit collision. So first we'll call private void on trigger enter. And this takes an argument of the other object's collider. So if that other object's tag, or the collider of its tag, matches my public collider tag that I initialized, that should be edited in the Unity editor, I'm going to invoke the enter event. Likewise, for the stay event, I'll set up on trigger stay. And then if the tags still match, I'll invoke the stay event. And lastly, I'll have on trigger exit, in which I will invoke the exit event. And then I can save. Now, when I go to the Collider controller manager, now when I go to the Collider controller, also, I don't think this should be a child of managers. Let's leave this as separate. So when I go to my Collider manager, you can see that it's giving me some events that will occur on enter, stay, and exit. I also have that public collider tag that I can set up. I want to make sure that this box collider is set to trigger as well. And I'm going to set the collider tag to be left hand. So this predefined tag will correspond to the game object layer tag of the same name that we set in the layer settings. So in this case, we'll be using left hand as the tag, but you can choose any tag as long as the collider tag and the layer tag match. All right, so I'm going to click plus for all 3 of these events so I can dictate what happens. I'm going to add the collider controller object for all 3 because I want to call its enter, stay, and exit. So for all of these, I'm going to go to the mesh renderer material, and set it to different materials. So if I go here, do my materials from chapter 4, click on this again. I'll choose red emission for the enter event. For the stay event, I'm going to choose a green. Let's go with green unlit. That's when it's holding. And then on exit, we'll go back to the original blue transparent that it already has. Oh, let me make sure that I this set. Because when we exit, we wanted to go back to the default material that I had originally. Now, when I go to the left-hand controller game object, I want to disable is trigger on the collider. So compared to the boxes, the box has is trigger enabled, and we disable trigger on the left-hand collider because we only need one collider in action to have on trigger set up. Now for the layer, we need to make sure this, and this is going to be case sensitive, so let's create a layer because it looks like we don't have it already. And we should call it left hand. It should be capitalized the same way as we defined it. So if I click on left hand again, make sure it's the one that has the collider on it. I'm going to set it to left hand. It says, do you want to set this for all children? Sure. They have another demonstration where you set up another basic collider controller where it scales up and down, and on exit it sets to scale null, but you could do that for your own practice. It's looking for tag and not layer. Maybe I should create a new tag called left hand instead. And then I can give that to the left controller as well. Let's try it again. Okay, so now when I go to touch it, it works. Okay. Kind of hard to see when it turns red immediately. It pretty much instantly goes to green. It's hard to see the red on collision part probably. So next is essentially combining the two, where you have collision and input interactions. So that could be in order to grab an object or pick up an object. Maybe you'll need to be touching it and pressing an input at the same time. So for that, we'll create a script I accidentally created ahead of time. That'll be called collider input controller. That deals with collider and input. This is what it'll look like. It'll have the action asset and reference. With 4 actions, we'll have enter, stay, exit, and also an action event that will be invoked here. So we'll have private, void, enable. That will enable the action asset. We have disable. We have on trigger, enter. We'll do the same thing as the other script where we invoke, but we'll also take this action reference performed and send it as a callback context. And if this is performed, first it will be incurred during the trigger enter, and it will be removed when we exit. So we're only allowed to perform the action while in contact with the trigger, and we can do that here. So once this script has been written and saved, we can duplicate this collider controller. So I can press Control D, and we'll rename this as collider input controller. Delete the one. We'll remove this collider controller script and instead apply the collider input controller script. Here, we'll give it the same tag as left hand. Now, the action asset should be the XRI default inputs. And the action reference, in this case, we're going to use the secondary button. That's the first one that shows up here.
Let's move this somewhere. Let's actually move this so we can differentiate the two over here. For the enter event, we can go ahead and make it red, as with what we did with the other object. You go to mesh renderer, material. Maybe drag red metallic in here. We won't be able to really see it. We won't have a stay event. For the exit, we'll have it go back to its original color again. In this case, let's make it like a yellowish color. We could just reuse the light gray material. So make sure you drag its game object in, and for its mesh renderer, material, drag the same one in. Now we also have this action event. This will be performed when we press that button. So what your book does is it actually decides to scale down the sphere for this, which you could have it do whatever you want, but so we'll actually be able to interact with this object to make another event happen with a different object. So maybe it could be a button that activates a door or something like that. So if I go to toggle scale, because the sphere has toggle scale, and I'll click scale down. So that'll occur while I'm pressing the button. And in order to not have it scale down forever, let's give it the sphere again, and instead have it call scale null so that it stops scaling once we exit. So maybe you could have two different action references, one for making it larger, one for making it smaller. You could define them here. So remember, we had two action references, scale up and scale down. You could have more than one if you wanted to implement it that way. All right, I was pressing the triggers. If I press the second, so if I put my hand on, it turns red, and if I press the secondary button, it causes the sphere to grow, but only when I'm in contact with this, and it stops, or if I let go. All right, so the last thing we're going to do is use colliders and Unity events to create portals, and that'll allow the player to instantaneously be transported to other locations on the map, which can be important for VR development for seamless transitions. Maybe you could have them load different scenes for you to prevent having to load your entire game in one scene. You can have them be transported from one location to another or scene to another. So in order to make our portal, we could create an object from ProBuilder. I'll go to create empty, create an empty game object and call it Portal Manager. Then I'll create an empty game object as a child and call it Portal. I'll set this to the origin for the parent object and have the portal's X position at 4. So it's going to be over by cylinder. So maybe I want to move this out of the way. So I'll add a ProBuilder object. I can right click, click ProBuilder, and there's actually a door preset here. So this can be a child of my portal. I'll set its transform to zeros and drag it onto my portal object, so that'll translate it. Looks like I probably should make it 0, 0, 0 after that, so here we go. And we're going to name this as Portal Frame. So rename Portal Frame. I'm going to give it a material. I'll give it a yellow specular material. If I go red specular 2, technically yellow, it looks something like this. My bad, my rotation. I'm going to set the Y rotation to 90, such that it's facing the edge of our plane. Set the Z position to be 1.5, so it's aligned over here. I'm going to add a cube game object as a child of this, so I can right click 3 object cube. And I'm going to name this portal door. So this will be what you're walking through. And it's going to have some kind of trigger to detect our player. So I'll right click that. And as for the size, I'll set its scale to 3 for the X, for the Y 2.4, and for the Z 0.5. Its Y position will be 1.3. Its X position will be 0.5. Looks like I'm gonna have to move it a little bit in the Z that lines up. It looks like they kind of botched the transform in the book. Something doesn't look right, so I'll just kind of fit it myself. We're gonna drag on a blue metallic material for this. Okay, let's just have it be something like this. So I have 1.5, 2, and 0.5. And I'm gonna make one other object. So I'll create a empty. And I will call it portal anchor. I'll set its position to 0.5 on the X. And then we'll create a new C# script. We'll go to scripts, create, and call it portal manager. I'm gonna have a public string for the player tag to make sure that it'll only do this to the player. Public game object destination. This is where it'll send you. And we also need the player's game object. Public float portal cooldown. We need a portal cooldown because let's say that there's a two-way portal and you're constantly, if you're touching those triggers, you'll be sent back and forth between them repeatedly, and we don't want that. So we'll have a cooldown time. And then we'll have another boolean that's private called on cooldown. So for the start, we'll set the cooldown time to 0. So that implies that you have not recently been teleported. And the on cooldown will be false to start off. Then during update, if it's on cooldown, we're going to want to count that down and make sure we're not activated. So if it's not 0, we'll take our cooldown time and we'll decrement it every frame. So this time.delta time is the interval in seconds between the first frame and the next. So it keeps a live, accurate time for us. And if this cooldown time is less than or equal to 0, why are we setting it as less than or equal to 0? Well, this is between frames. So this is the time between frames. So it is possible we could get a result that's less than 0. And once we get there, we'll set this equal to false. It is no longer on cooldown. Now we're going to define some other methods. First, we'll have the start cooldown, and that should occur as soon as cooldown is true. So if we're not on cooldown, so this should probably get called once you actually use the portal. So it'll initialize the cooldown time to whatever we set as portal cooldown, which we've determined to be a public float, so we can change that manually during playtesting. And on cooldown will be true. So if it's false, turn it to true and initialize the amount of time to count down. Next, we'll make another private function called onTriggerEnter. That's one of the built-ins or default in the Unity library. You can see it gives me the collider other, and we're going to be looking for the player here. So I'll do if other.gameObject. So that's the game object attached to that collider, and its tag is equal to player tag, which will define whatever we type in up here. Oh, looks like I spelled that wrong. And it's not on cooldown. So we want to make sure that it's also not on cooldown. So if the portal is on cooldown, we'll need it to not be able to function until it reaches 0 or below. So once this happens, we're going to send the player to the destination. We'll also start the cooldown. So we'll call that. And we're going to take the player and their transform, specifically their position. We don't want to rotate them. Well, we can, but we don't have to for this case. Destination.transform.position. Oh, there. So this will go to whatever we choose for our destination's position. So that'll be some game object. It could be empty that we set up. This will be where the player ends up after going into this portal. So we'll save and compile this. And we'll add this script to the portal game object itself. So I go to Portal Manager and click on Portal. So it's looking for the player tag. We should set that to player and make sure that the player has that tag. We go to our origin. Maybe we should create a new... Oh, it's already created. Okay, so we've given it a player tag. Maybe you could override that prefab if we want. So for the player object, we're going to take the XR origin, which that kind of makes me wonder, well, why can't we just reference the player by this since we have its game object rather than the player tag? But that beats me why they're doing it that way. They didn't have to. But for the destination, we are going to set up something for that. As for the portal cooldown, we'll set it to 3 seconds. So what we'll do is we'll set up another plane. So we could duplicate this. So we can put this wherever we want. We could drag it over to some remote location over here. And we're going to place a second portal so I could duplicate this. Copy and paste. Or duplicate. So I can duplicate this and make it a child. Set it at 0, 0, 0. So it's at the origin of this. So for the location, we can just take the opposing portal. So this is the portal associated with the second plane, so we could drag the first portal's transform in. This is the location for the other portal, so we can drag that in as reference for the destination. And if we have any issues with this, we could probably raise it a bit. We don't want our player to be in the ground and to fall out. So it looks like the box collider is on the portal door, but not on the actual portal that has script on it. So either I followed the instructions from the book wrong or something was wrong with the explanation, but that just means we should give the box collider to the actual portal instead, since that has the script. So we can give it its own box collider. Set it to isTrigger. And we will want to align it with the portal door. So I'll check this off because we won't need this one. I can actually just remove it entirely if I want. I need to make sure that the trigger lines up. There it is down there. I want to raise it a little bit in the Y. Scale it too. Probably copy these for the door. So set it to position is 1.5, 1.2, and its scale is 0.5 to 0.5. 1.5 to 0.5. 2.5. It's likely because it had been rotated. Let's just try to fit this. So it should be something like that. Make sure it's set to isTrigger. So I'll just go ahead and make the same changes to the other portal. I can copy component, go to my other portal, And I will remove, again, the collider from the portal door and just add it to the portal, my component collider, and paste component values, and it sets it up for me that way. Hit save, and we'll try again. So from the looks of it, it kind of looks like I get teleported. I'm jumping, but I'm not jumping to the other portal. So let me see what this reference is. Oh, it worked. Okay. So it looks like what we should have done is make the player not the XR origin, but actually the rig. I need to drag the rig into both of these, so that's what ended up fixing our issue. So I should take both these frames and give it the most parent object, the rig. So let me try it one more time, see what this looks like. Actual play mode, rolls with a 3-second cooldown, so I don't just immediately walk through. Now I'm on the other side of this giant kind of gap between the planes. Walk through again. Oh, there we go. Well, it dropped me off behind the other portal, so you could probably fiddle with it and choose a different location to spawn you at. That's just part of tweaking this. But essentially, that's how these portals work. Earlier, I mentioned that you can use portals to swap between scenes too, because again, maybe we don't want to have a large single level. We want to have multiple levels and allow the player to walk through a portal to transition from one scene to another. So let's go ahead and let's go ahead and make the portal a prefab too. I can go into my prefabs because I may need to reuse this and drag it in here. That's my portal prefab. Okay, so it did actually get the door frame, and just can't really see it with the material that was chosen. I don't really like that we chose the see-through material, the specular. Let's go ahead and choose something else. Let's just go with the regular. Here it is, the standard instead. Go back. They shouldn't be. They are still see-through. Looks like. I guess that didn't totally help. That's okay. I think it's just the way that the mesh is generated from Pro Builder. It's a bit strange. I would probably make it in Blender, to be honest. It's a pretty simple geometry. Anyways, what we're going to do is we're going to make another scene. This is chapter 9, I believe. I don't know. Oh. So we're going to make a new scene here. Create scene. And this one we'll call Demo Room Scene. So we have a new scene over here. And we're going to delete the main camera because our rig already has one. We'll add the demo room prefab that we have. So here's our big old demo room is back. And we'll add the VR rig with the physics prefab over here. So now we're going to duplicate the portal game object and call it portal scene. So here's one of our portals. We drop it at 000, that's fine. And we're going to rename this as portal underscore scene. So this will be a variant essentially, because we're going to give it a different script. So we can place it in some kind of location on our plane. Maybe we want to have it over here. I don't want my player to walk too far to access it. Let's just put it here. Right here. So we're going to remove the portal manager script that we had earlier. So let's remove this. It's giving me this annoying thing, this little notification here because this is a prefab, so it might help to unpack it. Should be something that says unpack prefab. Here it is. Unpack completely. Now it stops giving me that issue. So I've taken it apart separately from the prefab. And we're going to make a new one, a new script, and we're going to call it Portal Scene Manager. Create and add. So that'll add it to this, and it'll also create a new one for me once it loads properly. Oh, since I added it directly to the game object, it doesn't by default save it in our scripts folder, so we have to drag it in. Anyways, once that's loaded, we should be able to have it show up here when we double click. It's transferring it. Okay, so once I go here, double click Portal Scene Manager, that gets it open in Visual Studio, and I'm going to add the following. I need to use another library from the Unity engine called Scene Management. We're gonna give a couple names. So public string next scene. So it'll be the name of our other scene. We want to transition to public string player tag. So now we'll simply have our on trigger enter private void on trigger enter. And so we want to make sure there's no need for cooldown between these because we won't be going directly to another portal per se. So if other dot compare tag player tag, this is just another built-in method. So it says returns true if it has the same tag. This is essentially the same thing as writing other dot tag equals player tag. I guess they're just introducing this to say, hey, you can use this function too. And so from our scene manager that we have, our scene manager library, we're going to take a method called load scene, and then we just simply have to type in, it would usually accept a string or integer in this case, the next scene name. They have a next scene name, which might be a typo, I'm not sure. Yeah, I think they might have typoed this. These didn't match. Let's go ahead and just give them the same name and save. Okay, so now we're gonna make sure that we set our player tag to player in the inspector. Over here we have our VR rig again. Here you are. I think we made some changes. I want to double check. Make sure that our tag is player. I know I unpacked it. You could have made this set as a prefab variant of the other portal, but that's fine. Just drag it in. It'll be named as portal scene. So I have this set up. So the other scene, let's see. Since we're using potentially multiple scenes, we want to go into our build settings. So I go File and go to Build Settings. You want to, they have these scenes to build. We want to add one of them. Looks like it already added it since this was an open scene. So we have the demo room scene already built. So we won't need to, it'll kind of be loaded ahead of time, or at least put in this queue to load. So for changing scenes, you need to have all scenes that you could use, that you intend to use, in this scenes in build menu. So I'm just going to save it. We could actually just go to this scene over here, for example, and then drag our prefab in. Let's do this instead. It might be more interesting. You could actually see the change in scenes. So I have my portal scene. Where did that drop? Over here. Let's say I drag it over here. Give it that scene name. I think it was called Demo Room Scene. Player. And let's give it a try. All right, so this is the other portal over here. I might have flipped it backwards. It's okay. But once I walk into the collider, it takes me to our other room. And as expected, I walk into this portal, it should take me back to the beginning. Again, you can tinker with the the transforms. You can tinker with the colliders to get it to work on a more precise level. But that essentially concludes this tutorial. This one was a bit extensive in terms of the amount of functionality, but this is one of the most important topics in terms of being able to add your own functionality based on custom inputs and causing events to happen with these action managers. So the next chapter is a bit more brief on render pipelines, and I hope to see you then.